If you're working with containers, you're likely familiar with the concept of a Docker registry, where you can store your container images, which can then be used to launch your application containers. In this video, I'm going to show you how to set up your own private Docker registry on Linode using the Linode Kubernetes Engine and object storage. By the end of the video, you'll be able to push and pull images from your new private registry, and an LKE cluster will be able to pull images to run your application workloads. Hello, my name is Sid, also known as DevOps Directive here on YouTube. I'm a developer advocate working with Linode. If you want to follow along with today's tutorial, there will be a link in the description that will give you $100 credit when you create a new account with Linode, which would be more than enough to get started. Without further ado, let's get into it. So, we've got a lot to do today. We'll be covering the following: creating an LKE cluster, creating an object bucket to store the images, installing the Nginx Ingress controller into our cluster, configuring DNS for a custom domain, installing and configuring a cert manager to provision an SSL certificate, configuring and deploying the actual Docker registry, and then we'll demonstrate using the registry, pushing an image from my local system, and consuming that from a Kubernetes pod. There's a few software prerequisites that you need to have installed and configured before we get started. On our local system, we'll need to have Helm version 3, kubectl, and Docker installed. If you don't have them already, you should go to their official websites to get the latest installation instructions. We'll also be using a custom domain for our registry, so if you don't have one, you should purchase one from the domain registrar of your choosing. Here I am at cloud.linode.com, logged into my account under the Kubernetes section. First thing that I'm going to do is create a cluster. So I will call this private registry demo. I'm going to put this in the Newark, New Jersey region and choose the latest Kubernetes version. We can then select which type of Linodes we want to use as the nodes for this cluster. I'm going to create one with we'll just use 2 of the 2 GB Linodes. If you have more resource intensive applications, you could add larger or more nodes to the cluster. We'll add that, and then we'll click Create Cluster. This can take a few minutes, so I will speed up the video in the meantime. The cluster is still provisioning, but it does have this kubeconfig file now that I can download and authenticate my kubectl command line to this cluster. So I'll download that. And then I'm going to move it into this directory that I have set up here. Don't worry, I'll delete this cluster before this video goes live, but this is a secret file that you want to keep secured. By default, kubectl is going to use an environment variable, kubeconfig, to tell it where the configuration file to authenticate to the cluster is located. Here, I'm going to use my present working directory and then the name of that file. Now if I do kubectl get nodes, we can see that there's one node in the cluster and it's not ready yet. That'll change to ready, and we should get a second node once the cluster's done provisioning. The next thing that I want to do within the Cloud Linode interface is go to object storage. I'm going to create a bucket, and this is where the files associated with each container image will actually live. I will call it private registry demo, and I'm going to put it into that same region that the cluster is in. Great, that looks okay. Looks like one of our nodes is now ready. Let's continue on. Next up, I'm going to install the Nginx Ingress controller into the cluster to handle traffic coming from the outside world. To do this, I'm going to use a tool called Helm. First, I'll add the repo where the configuration for this application is stored. Then I'll run Helm repo update to make sure we've got all the latest changes. Finally, I'll use a Helm install command to install it with the default configuration. Now if I run kubectl get pods, we see that Ingress controller, and this is all running in our default namespace. There's also a service associated with this Ingress controller. We see here, service is of type load balancer and has an external IP address associated with it. I'm going to create a DNS record pointing my custom domain to this external IP address. Within the domain section here, I have my domain, my super awesome site, already set up. I just need to go and add an A record. We'll call this Registry, point it to that domain, and we'll set it for a short TTL so that it'll get updated more rapidly if I have to make any changes. We can check if those DNS settings have taken effect, and they can take a little while to roll out by using the dig command. Dig plus short, then we'll do registry.mysuperawesomeSite.com. Now we didn't get anything back. That probably means those DNS settings haven't propagated yet. Because we want to talk to our Docker registry over an encrypted HTTPS connection, we'll need to generate a certificate that the application can use. In this case, we're going to be using an open source add-on called Cert Manager and installing that as a custom resource within our cluster that can provision those certificates. To do this, we can run kubectl apply on this URL, which has those definitions located there. Okay, looks like those CRDs were created. We'll then add a namespace for the Cert Manager resources to live with create namespace Cert Manager. Now we can do kubectl get namespaces. We see that Cert Manager namespace is now active. Finally, we're going to use another Helm chart to actually generate the certificate manager for us. It's located at charts.jetstack.io. We'll update our repos just to make sure we have the latest. And then we'll do Helm install Cert Manager jetstack /Cert Manager, and we'll do it into the namespace Cert Manager. Looks like it was deployed successfully. Let's go ahead and look at all the resources in that namespace. We see there's these Cert Manager pods, this webhook, a couple of services. Awesome. Now that the Cert Manager is deployed, we need to create a cluster issuer. That cluster issuer will actually have the certificate authority to create our certificates for our applications. To do that, I'll make a YAML file defining that resource. Acme issuer prod.yaml. Within that file, we'll define the kind cluster issuer. It's named Let's Encrypt prod because we'll be using Let's Encrypt to get those actual certificates. I'll update this email. And that should be good. This is the production URL for Let's Encrypt. They do have a staging version where you could put staging here, but I'm going to use production for now. If you fail too many attempts with the production endpoint, it will lock you out for a little while, so be aware of that. Let me apply this resource, and this is a cluster-wide resource, so it doesn't actually matter what namespace it's in. kubectl apply-f acme issuer. There we go. With the issuer created, we can now obtain the actual certificate for our application. Once again, I'll create the YAML. This is of type certificate. It's named Docker Registry Prod. You'd give it a duration for how long the certificate should last, as well as how long before it expires Cert Manager should try to renew it. I now need to update this DNS name to match that of my registry, mysuperawesomeSite.com. And it's going to use that cluster issuer that we just created. Let's go ahead and create that. kubectl apply-f certificate prod. Now we can do kubectl get certs, and we can see that the certificate we just created is ready, 35 seconds old. With that taken care of, we can actually deploy our Docker registry. We're going to need to do a little bit of configuration before we do so. Because we're going to use basic authentication, that is, a username and a password to log into our Docker registry, I'm going to use a utility called htpassword to do so. First, I'll create a file called my.dockerpass. Then I'll use htpass, the -b flag to force it to use bcrypt. I'll pass it my dockerpass file that I just created, and then this will be my, and then the username, example user. Password will be password123, very secure, password123. So now this my docker pass contains our example user and an encrypted version of that password. Once we have the application up and running, in order for Kubernetes to be able to download the necessary images to deploy pods and other resources, we're going to need a secret inside the cluster containing these same credentials. In order to do that, we can use the kubectl create secret command and update it with our appropriate values. The secret will be of type Docker registry, and it'll be registry.superawesomesite.com. We used example user, and the password that we used was password123. Docker email, we'll just use sid@devopsdirective.com. So now that secret that we just created, regcred, has our Docker config within it. The Docker registry itself is also going to use a Helm chart to deploy, and it takes in a configuration file that we need to make some changes to. I'll start with the boilerplate here. We need to add our host. We need to put in the contents from our htpassword creation. And now we need to grant it access to that object storage bucket that we created at the very beginning. Now, in order to get these access keys, we're actually going to go back to the cloud interface. Under the object storage portion and access keys, we can click create access key, and we'll call it private registry demo. By default, it'll have access to every bucket in this account. I'm going to limit it just to this one bucket, even though that's the only bucket I have. Now we'll copy these values in. So our key is there, and our secret key is there. Once again, I'll delete that bucket before this video goes live. I then need to update our bucket name to private registry. And finally, I need to update my hosts here in the TLS settings. It's going to use that secret name that we created before. And now we can install the Docker registry Helm chart. It'll be Helm install Docker registry. It's our release name. The Helm chart is stable/Docker registry. And the file we're going to pass in is that docker configs.yaml. We'll do kubectl get pods. And it looks like our registry pod is running. Now that it's been deployed, we can go to registry.mysuperawesamesite.com, and we see that we have this valid secure connection to the registry. In order to test this, I'm going to pull an image to my local system, tag it to be pushed to this private Docker registry, push it there, and then create a deployment on Kubernetes to use that. Let's go through that workflow now. We'll do Docker pull on this Hugo site image. This is just a basic static website built with Hugo. I can now use Docker tag to take the tag that was on that image and map it to our new registry. So here I'll do registry.mysuper. Great. Now I'll do Docker login on my new registry. Our username was example user, and our password was password123. Login succeeded. Awesome. Now, if I push that image tag that I just had before, so I'll do Docker push. This is now being uploaded from my local system into the registry living in LKE. Great, it appears that it's there. And now I'm going to create a test deployment using that image inside the cluster. I'm going to create a new DNSA record for the static site that I'm going to deploy. Once again, we'll look at the services. We'll get this external IP address of our Ingress controller. Going back to the domains portion here, I'll create another A record. This one will be static and point to that same IP. The first thing that we'll create is a deployment. It'll be relatively simple. We'll have 3 replicas. Its name is going to be static site. We need to pass it the private registry tag that we pushed our image to. So once again, registry it's going to be exposed on port 80, and it's going to use that secret that we created earlier named regcred to authenticate to our private registry. Okay, that looks good. We see these 3 pods creating, and they're running. That's a great sign because it means that we were able to authenticate to our private registry, pull that image, and create those pods. Next up, we need to create a service for this deployment so that we can access it. To do that, I'll create a service.yaml file. It'll be of kind service. We're naming it static site. We're going to use a type node port here, where we're going from port 80 to port 80, because that's what our container is listening on. It's selecting the app that we had in our deployment using the app selector static site. We'll just apply that resource. Great. And then the final resource we need is of type Ingress, and that will allow us to get traffic from our Ingress controller to this service. It'll be of type Ingress. We're going to name it static site Ingress. It's going to use the Nginx controller that we have deployed into our cluster using HTTP. We need to update our host, but otherwise everything looks good. So it'll be static.myAwesomeSite.com. And it's going to pass the traffic to this static site service on port 80. So now if I navigate to static.mysuperawesamesite.com, I should be able to access that site. And there we have it, our static website deployed into Linode Kubernetes Engine using a container image that we stored in our private Docker registry, also running inside that same cluster. Hopefully this is helpful if you need to start working with containers on Linode and have a need for a private Docker registry. If you liked the video and want to see more like it, make sure to subscribe to the Linode channel. Also, let us know in the comments section the types of videos that you'd like to see in the future. That's it for today. See you next time.